Look at Module 3. I am late, so I'm not going to do the news, but I've got Module 3 should be available here. All right. There we go. All right. So the hardware is pretty important. You have to know how data is stored to do forensic work. SCSI is one protocol, one kind of a cable used to connect devices together. And so there's a picture of SCSI cable, I guess. Looks like IDE to me, but I think that's IDE cable. Anyway, that's one type of SCSI. That's one type of way to connect a hard drive to a computer and other peripherals together. An older one is IDE. The more modern one is SATA. That's PATA. The modern one is SATA cables. Yeah, this is what almost everybody uses these days, these red cables with the L-shaped hole on the end. That's faster and more common. Anyway, they're all different types of devices, and you find them if you get to do the A+ course around here. But the typical way you copy data off a hard disk is you power off the computer, you pull out the hard drive and connect it to a device and image it. And the reason you do that is because you want to copy every bit of data on the hard drive without changing anything. So you connect it through a write blocker, which is actually a complicated device costing several $100s now, unfortunately. Now, back in the days of these cables, these parallel ATA cables, you could just cut one of these wires, and one of these wires was the write wire. So you could make a write blocker that easily, but not anymore, because modern operating systems always write on the hard drive. As soon as you boot it up, it touches the hard drive, and because modern operating systems are all journaling, it starts putting records in the journal. And it updates the time date stamp on the recycle bin. It makes a bunch of changes on the hard drive just as soon as it connects, before you're saving any files or anything. So the write blocker has to sit in the middle and lie to the computer and tell it that it's making all those changes without actually making them. So it has to be a little computer with storage and programming in the write blocker. That's why they cost a few $100 now. All right, so a clone is an exact copy of a hard drive, can be used as a backup. An image is an image that has all the data from the hard drive, but it's not bootable typically, because it's just in a different format. For example, it's usually compressed because drives are big, and it's irritating to move these really big files around when most of them are just zeros anyway, so you zip them. And that's like the E01 format is the most common, which is a compressed format. You can get devices just for cloning hard drives. You plug one in here, you plug another one in there, press a button, and they clone, and that's fine, and this is what some people use. But you have to make sure. Now here's something a lot of people recommend. You have to sanitize the hard drive first. This is a recommended procedure from my best forensic teacher, that you always should have a clean hard drive to put the data on. Now this 7-pass DoD approval is pretty much nonsense. 1 pass of zeros is enough to clean any modern drive. But anyway, some people still run the old 7-pass just out of an excess of caution. Anyway, SSDs, of course, are mostly what we're using now. And by the way, I've been listening to Security Now, Steve Gibson's podcast, which is really excellent, and I highly recommend you all listen to it. And one of the many things he explained is he makes most of his money from a product called SpinRite. He is an awesome hard drive expert, and he writes all of his programs in raw assembly code. He doesn't bother with higher level languages at all, which is actually quite practical. Once you learn how to write assembly and get organized, it's really not hard to do everything in assembly. And the point is, he understands exactly what's going on with every bit on the hard drive. So if you have a hard drive and it doesn't work anymore, or it's running slow, SpinRite will fix it and make it run accurately and fast. He knows all the errors that occur on hard drives and knows how to fix them. And the same thing's true of SSDs. In his last show, he talked, and I didn't know this at all, SSDs are analog storage writing. When you write on them, it stores an analog copy of a bit, and it leaks from the area you write into the areas next to it. So as time goes on, it degrades. So in order to keep the data there, the SSD adjusts the threshold for how much of a deviation there will have to be to make a 1 down, so it starts making more errors. And so he had a hard drive where a guy said, my computer's really sluggish, and when I ran it through your testing tool, it should have had a read-write speed of 540 megabits per second, but at the start and the end of the drive, it was down to like 10 megabits per second, which is why everything was so slow. And he ran SpinRite, and it was back up to 540 all the way. So it's very interesting. There's a lot of interesting stuff you can learn about hard drives and SSDs. But anyway, for At the simple level of forensics that we're talking about here, the only really big issue about SSDs, they're the same as hard drives, except you usually cannot recover deleted files because they're deleted in the background, they're erased in the background with a garbage collection routine. Yeah?
Just because you mentioned assembly language.
Yeah.
When we deal with assembly language, are we using the hexadecimal system?
Well, not usually. You usually use mnemonics like add and multiply and move and branch. They are all reduced to hex codes. It can only execute as hex codes, but you use an assembler. That's what an assembler does. It's analogous to a compiler. An assembler takes those alphabetic, somewhat human-readable codes and turns them into hex codes. But the only thing that, yeah, just like a compiler would take C or Visual Basic and turn it into executable hex codes too, but it goes through a couple of stages. And assembly is much closer to the hardware and the processor, though. Yeah, because the commands you use are specifically commands in the processor. Whereas in high-level languages, you don't really know what commands it's going to make. Like you say, if for I equal I in range 1 to 20, do something, print something, and you don't really know which system call it makes for printing. You don't really know how it stores that variable or anything. You let it make all those decisions for you. And so you don't really, it's like an automatic car. You're not really controlling what it does in detail. You're only controlling the general motions when you write in a high-level language. If you really want to understand exactly what it's doing to every bit, you write an assembler.
And am I correct in assuming that the binary code of the machine language is on top of the assembly? Assembly very basic?
Assembly is very close to the hardware. All assembly code is you take the raw hexadecimal codes that are built into the processor and you write somewhat human-readable mnemonics for them. So instead of just having to write, like I remember on the old, I still got some of them memorized from the 6502, and A0 is load accumulator from memory. And instead of having to remember that it's A0, you could just write LDA and then an address. That's all. It's only a very small step from just writing raw machine code. That's why you're in very good control of the machine. But therefore, it takes a lot of steps to accomplish things, and most programmers program in higher level languages because they just want to get a job done, and they really don't care exactly how the bits and bytes are used in the machine. But if you really do care, then you write assembler. Yep. Anyway, so SSDs are more efficient. They are faster. They use less power. That's why they're in cell phones and in portable devices like my Mac here and all over the place now. They're also more expensive, but most people are willing to pay for that for the improved performance. So recovering deleted files is more challenging because most of them have garbage collection, and the reason for that is you do have to erase regions of SSD before you can store new files on them, which is not true of magnetic hard drives. In magnetic hard drives, you just write on top of the previous data without erasing it, which is why it just leaves the old data there. That's most efficient. But SSDs, you do have to erase it, and when you erase it, you have to erase it in big blocks, I think 640 kilobytes, all contiguous. So in the background, it is moving your stuff around to create big open spaces and then erasing them. So it's ready to store more data. That's why it doesn't 100% erase all the deleted files, but in practice, almost all the deleted files are destroyed gradually in the background. And it's fun to watch. I did a talk at DEF CON where I had this set up, and I wrote a program where I could save things, and you could watch it happen. You could save something, delete it, and it would stay there for about 15 seconds, and then poof, it would be gone, because the background garbage collection runs later. Anyway, all right. And that's what it's explaining here. It has to erase large blocks before it can go. So that's the difference with SSDs. Now, RAM is memory that is not intended for long-term storage at all, although it lasts longer than people might think. You store data in RAM while you're using it, and when you turn off the power, the RAM will forget. But that does not happen immediately. In fact, it gradually fades, and if you cool it, it can last for a half hour or longer. So there are some cold boot attacks. This is how you break into a machine where the hard drive has been encrypted with BitLocker. If you can get it in a sort of suspended state, you can open the case, freeze the RAM, because the key is in fact in the RAM. And pull the RAM out, put it in another machine, read the RAM, and find the key. That's the Stanford cold boot attack, which is pretty awesome. And all hard drive encryption schemes are still vulnerable to that, which is why if a computer is in like standby, it's vulnerable. Then the key is still in RAM. If it's 100% powered off and the RAM has forgotten, then there's no way to get in. Except for an even more exotic attack that Joe Grand did it, where he actually took the Trusted Platform module, which is the special cryptographic module that stores the secret key, and he dissolved it with acid and reached in with a tiny needle and found the pin and was able to suck the key off that way. But he said he had to destroy 100 GPMs to make it work once. That is like truly heroic. You'd only do that for something that's really, really, really important. And that's the sense in which hard drive encryption protects your data. Nothing is ever perfect. But the only, once a hard drive is encrypted, it would take outrageous, heroic things like that to get the data off it. Now, hard drives fail, and they often fail spectacularly, where they just lose all the data and don't work at all. And so it's not enough just to have one copy of the data. If you want to have, now if you had one copy of the data and you had a backup, then when it failed, you'd be down, but you could restore from backup and come back up. And that's possible if you're willing to put up with some period of downtime, like an hour or two. But if you're not willing to put up with an hour or two of downtime, then you need a high availability solution, and that's what RAIDs are. RAIDs are not backup, because think of this, if the building burns down, you don't have another copy of data. That's what backup is. You make another copy somewhere else, so if the whole building burns down, you still have the data. Backups are for disaster recovery. But for high availability, you make RAID arrays, because if one of these drives fails, there's extra copy of the data on the other drives, so you continue to provide service to the customer, even though a drive failed. And a light will come on, and you can replace the drive, and it will rebuild the data on that drive. So the idea is now you can have higher uptime. 2 or more of these drives would have to fail, and with larger RAID arrays, it can be many drives have to fail before you actually stop serving the customer. That's the point of redundant systems like this. And another system is FireWire. I think it's one that Apple used for a long time, another way to connect hard drives to it. And of course, USB flash drives. These things were all over the place. I think people still use them. They replaced floppy disks essentially, and typically the data is stored with the FAT file system, so there is no permission. If you actually format a USB drive with NTFS and save data, it will be tied to the account you were logged in on that machine. And when you plug it into a different machine, it won't let you in. So that's pretty annoying. So that's why nobody much uses NTFS on those things. You use FAT, which doesn't have any permissions. Physical access to the drive is enough to have permission to get in. And then, of course, external hard drives. So we have a whole hard drive from a laptop in a case. This way you have a lot of storage. It's good and fast. By the way, I have students whose home machines are all full and they're trying to run virtual machines. In my experience, you cannot run a virtual machine successfully from a flash drive, but you can from an external hard drive. I don't know exactly why. I just know it's true in practice. I think the read-write speed is not fast enough for the thumb drives. But these external hard drives run virtual machines just fine. Anyway, and so you can use these for backup, or you can use them to just add more storage to your machine, or to move data from one machine to another if you allow either format them with FAT, or you can, by the way, have NTFS and allow full control to everyone. You have to go to some work to do that, but you can do that, and then you can move an NTFS device from machine to machine without getting locked out. Let me check the Twitch. Can they put a real look in the RAM? I'm not sure what you mean. Maybe a real lock in the RAM? Give it to me, Scuzzy. Yeah, I don't understand the question. RAM just stores data, and by the way, right now there are no permissions in RAM, which is a problem. It doesn't have any owner, it doesn't have any permissions. In modern operating systems, it's possible to mark regions non-executable in the RAM, but it doesn't have, the only thing, in principle, you could encrypt the data in the RAM, and there are some solutions coming out now that do that. They call this encrypting data in use. So that even if somebody was to read your RAM and steal it, they still wouldn't be able to get in. There are some products that do that, but they're not in common use yet. Anyway, then you got these removable cards. They're basically the modern version of floppies, multimedia cards, SD cards, quite common on cameras and other devices. And anything you plug them in, they're formatted with FAT, so physical access to it means you can read all the data off them. And of course, these are all over the place, compact flash cards, these memory sticks. These are all essentially the same thing, just different formats, different drives needed to read them. All right. And again, all of these, if you want to take forensic evidence off them, the best practice is to use a write blocker. Although you might have to buy a whole bunch of write blockers to fit all these things. And this is where I mentioned many times in this forensic class, because I lived through it. When you cannot do the perfect thing, you can do an imperfect thing, but keep good notes. You do not have to be perfect. You do not have to have the best equipment in the world. You have to make notes of what you did. When they go to court, you can say, here's what I did, here's what I found. And if it wasn't the perfect thing to do, just don't lie. This is what I did, and if somebody wants to yell at me and said I should have been a better forensic investigator and had better equipment, that's possible, but I used what I had. This is what I did. And if you make a mistake, I accidentally erased this data, write it on the document, admit it. The worst thing you can do is lie. The cover-up is 10 times worse than the disease. I mean, nobody's perfect. But whatever you do, write down what you really did and tell the truth. Of course, it's nice if you have the best equipment and can do the best job, but maybe you can't. All right, compact discs, of course, these optical discs, we have CDs and DVDs and Blu-ray, all of them are similar. They have metal layers that can have dark spots created in them with a laser, and they can encode data that way. And some of them are erasable and rewritable, some of them are permanent like CDRs. All right, and there are a lot of these options out there. And then, of course, there are floppy disks. If some of you have really old machines, I've done cases like this, although that was 20 years ago, so it wasn't that rare. Just get a stack of these things with a rubber band around them, and that was the data. And you have to figure out how to get it off of there. And there used to be these things called zip disks. They're sort of big floppies. I haven't seen any of them in 10 years, but, you know, especially at companies and sometimes at crime scenes, people have really old stuff. That's why sometimes one thing recommended in some forensic training courses is to make contact with user groups. You might go someplace and they have like an Amiga. I don't know if any of you remember an Amiga. Amigas were the cat's meow like 30 years ago. And so nobody has any cables that connect to them. Nobody understands how to take them apart, but there's going to be a users group. And they might actually have one. They might actually have somebody that knows how to read this data off that. Sometimes you have to do that to read really old, junky crap. But more typically in a corporate environment, you only want to do the corporate machine, and it's reasonably modern and all the same. It's the police that have the need for all this. They go to a crime scene and people have old junk lying around and they want to get the evidence off it anyway. Anyway, all right. I think that's it for this one. I don't think there's another part to this lecture. So we should do a Kahoot. Let me find my Kahoots. I think I forgot them last time, but I finally remembered this time. Yes, all right. Yes. All right. Might be in my favorites, but might not be. It looks like it is not. So let's got to dig it out of here. Okay. On 3, there we are. Okay. Get in back there? Okay, good. All right. Well, maybe we got everybody that's coming. I'll wait a little bit more. What's that? You should go to use the City College Wi-Fi, and there's no password or anything. You just have to agree to the terms of service. It should be this one, CCSF Wi-Fi. We don't need to log in or anything. Did he get in? Okay, good. Wait a few seconds, not like we're in a hurry. Did you get in the Cahoots? Okay. You still can't connect. That's not nice. Did you get on? So go to kahoot.it. Yeah, good. That's important. It's no fun if you can't get on the internet. Put in that number and any name you like. That's you. Okay. Well, there's other people still coming in, so that's fine. We have this music to entertain us. You're in now? Okay. All right. Well, let's try to give it a try. All right, so what's the most common hard drive connector nowadays? It's SATA, all right, serial ATA, the modern one. All right. So what process makes a file containing all the data on a drive? Okay, now this is what we're talking about. Now, cloning a drive makes an exact copy you can boot from, which is not usually what you want for forensic examination, although it's better than nothing. Now, backups and copies only copy the active data. They don't copy the deleted files, because why would you want them? But a forensic examiner wants them. That's what an image is. An image is a copy of every bit on the drive, including the ones that are no longer in use because they're deleted files you might want to recover, and then compressed into a single file typically. That's what you normally make is a forensic image, which includes every bit from the hard drive in a compressed format usually, although you can make an uncompressed image and that's all right. But a clone is when you have to buy another hard drive of exactly the same size and then copy it bit for bit, which is something you normally only do because you're setting up a mirror to make a dual, it's a form of a RAID array. You can make a RAID 0, I think it is, which is an exact copy where you have two drives that are exactly the same. That way if one fails, you can still boot from the other. It's common for the C drive. That's what you'd make a clone for. And it's interesting, they're all very similar. Another copy of your data, but forensic examiners need to understand that an image is the one you want if you want to recover deleted files. Now, if you're looking at something like a shared volume on a network drive where many different people use it, then you probably only have the legal authority to get one user's files, so you cannot get the deleted files because you don't know who they belong to. All you can get is the active data, and then you just make basically a backup or copy. You copy the active data, that's all you can get. All right. All right, so what storage device may erase the old data automatically with garbage collection? When I tested them about 10 years ago, about half of them were doing this. I bet it's more than that now, because considered a good process for efficiency, so modern SSDs should be doing this more, garbage collection. All right, what storage device do you read with a laser? DVD or any optical drive, that's how they work. They just have shiny and dark areas to encode the data. X, tell me who they are if they want their points. Okay. Alex and Derek look like real names. May not, okay. Okay, so you're one of them? You're Eric, Alex? Oh, your son's name. Okay, so what's your real name? M-I-N-G-Y? Y-I? Ming-Yi? Okay, yeah, okay, see, like this. Okay, good. All right, good. That's good. All right, and X will have to tell me who they are if they want their points. I'm going to stop this recording.